Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's class we are going to discuss a numerical on the topic center of gravity of solid bodies. Let's go to the numerical. A body consisting of a cone and hemisphere of radius small r fixed on the same base rest on a table. The hemisphere being in contact with the table. Find the greatest height of the cone so that the combined body may stand upright. Actually, here it is a solid body which is made up of a right circular cone over a hemisphere. And this AB, that is the common base. Okay, common face or common base. And then here, this hemisphere that is going to be a rest on a table. And then this we can consider as the reference line also. Okay, we can consider as the reference line to calculate the y bar. Okay, this is the reference line or reference axis for the calculation of y bar. Here, since it is symmetry about vertical axis, x bar, we know that will be equal to radius. So that we are going to omit here. Actually here, along the table, over the table, when this solid is placed, what will be the maximum height of the cone over the common face AB so that the combined body may stand upright. In case more than the maximum height or the limited height, if you increase the height of the right circular cone, then this will topple, okay, at the sides. That by using the moment principle, we can identify. But here, that means that center of gravity for the stable equilibrium, that the center of gravity of the body should be preferably below the common point, that means common face or base AB. Maximum, it may coincide with the face AB corresponding to the maximum height. When you increase the height, the center of gravity of the solid body will be on a height, that means more than, that means it is over the common face AB. So what will happen? It will topple. Okay. So maximum, the center of gravity of the entire body, that can be at this point. Okay. So here, this we can identify by using moment principle. Why this has to be in AB? If it is more than AB, more than the height AB from the reference axis, then how it will topple? Moment principle or otherwise equilibrium, stable equilibrium conditions, we can identify that. But here, that proof or references and all, we are going to omit. Okay. So here, maximum, the center of gravity of the entire body that may coincide at the common face AB. Okay, that is, since CG of the solid body may coincide, okay, may coincide with the common face, okay, with the common face AB. Okay. So we know that for this condition, y bar, the distance of CG from the reference axis, that will be equal to the radius. So here we know the value of y bar, and we are going to find the maximum height of the right circular cone. Okay. So here, as usual, by using center of gravity concept, we are going to split the solid into two segments. This one, hemisphere, this is the first segment. The right circular cone, that is the second segment. Okay. So here, first of all, guys, the y bar formulas we derived in a separate video, center of gravity by moment method. That video link is attached in the description box of this video. Same way, the reference formulas for cone, hemisphere, rectangle, circle, semicircle, okay, that and all we discussed in a separate video. An overview of center of gravity. That link also attached with the description box of this video. So go to the description box, click the corresponding links, watch the two videos for the reference. That will be useful for better understanding of this numerical. Okay. So now for y bar, we know the formula. That is, here it is the volume. These are all the volume. So V1 y1 plus V2 y2 divided by V1 plus V2. So this V1 y1, V2 y2, these values we have to find to calculate y bar. Okay. So first thing, for the hemisphere, I'm going to take for the hemisphere. Okay. Hemisphere. This is the first segment. In hemisphere, you can see first thing, V1. For a sphere, it is 4 by 3 pi r cube, the volume of the sphere. It is half of the volume. So it will be that value divided by 2. We will get 2 by 3 pi r cube. Okay. In terms of cube. Here r, that is an unknown. So we just keep in terms of r. Then y1. The distance of center of gravity of the first segment. Okay. Probably it will be here. CG1. From the reference axis, that means the axis which passes through the bottommost point or line of the solid. That means through D. That is the reference axis for y bar. So from here to here, from the point, this one, if you had taken that is O, from point O to the CG1, that will be 3r by 8. From this point to this, that one will be 5r by 8. Okay, here again, r, we are going to keep as in terms of r only. Then the second segment, that is right circular cone. Okay, the second segment. Then V2, we know the value of volume of a cone, that is 1 by 3 by r square h. Here the maximum h that we are going to find, and r as usual r only in terms of cube. And y2, here you can see this is the base or face for the right circular cone. From that point, the CG, this will be CG2. CG of the right circular cone, that will be at a distance, that is h by 4. Okay, from this point O, the CG, that distance will be h by 4. From the base, we know that this distance, that equal to radius of the hemisphere or the face or base of the right circular cone. So from this point D to the center of gravity 2 of, that means center of gravity of the right circular cone, that distance, r plus h by 4. Okay, that will be r plus h by 4. Okay, so now just to substitute in the formula y bar. We know that y bar that equal v1 y1 plus v2 y2 divided by v1 plus v2. Okay, v1 y1 v2 y2 divided by v1 plus v2. So here we calculated v1 y1 v2 y2. Substitute the values here. Okay, so first of all v1, that is 2 by 3 pi r cube. Okay, multiplied with the value of y1, that is 5 r by 8 plus v2 1 by 3 by r square h. Okay, multiplied with y2, that is r plus h by 4. Okay, this is the numerator, divided by v1 plus v2, that is 2 by 3 pi r cube plus v2 1 by 3 pi r square h. And we know this equal to, that means the y bar value equal to r. Okay, y bar equal to r, because to avoid the tuple, the center of gravity preferably below the point AB, maximum it can coincide on the face AB. Okay, for corresponding to maximum height. If it is above the common face AB, then it will tuple. So we can write y bar that equal to r. Okay, so this value that equal to r. So here, then simplification. This is the denominator that can be multiplied with the r. Okay, this value cross multiplication multiplied with the r. So we can write 2 by 3 pi here r cube multiplied with the r. That is a cross multiplication. Okay, then we will get r power 4. Then plus 1 by 3 pi. Here we will get r square multiplied with the r, that is r cube h. This will be on the left hand side. That equal to, on the right hand side, the numerator will be there. In numerator, we can say the simplification. Here 2 and this 8 we can simplify 4 times. So here you can see it will be 12 in the denominator. In the numerator, pi r cube multiplied with 5r. So 5 pi r power 4 by 12. So we can write this as 5 pi here r cube r. So r power 4, the denominator 3 into 4, that is 12. Okay. Plus this term, this 1 by 3 pi r square h, first multiplied with the r, then 1 by 3 by r square h multiplied with h by 4. So we can say here, first 1 by 3 pi, this one, r cube h, plus this h by 4. Okay, 1 by 3 pi r square, h square, and this 4 if we multiply, then we will get 12. So pi by 12 r cube, sorry, r square. Okay, r square and h square. Okay, pi by 12 r square h square. So now all the values we put. This one on the left hand side, this is on the right hand side. Here in each term, pi r square is a common. So we can take left hand side pi r square as a common, right hand side pi r square as a common, then we can cancel. or we can write like divided this equation pi r square on left hand side and also the right hand side. So then simplification will be here the pi will cancel. When you divide by r square, here it is r power 4, then it will become r square. Okay. Here pi r cube, pi cancel, r cube by r square, then it becomes only r. On the right hand side, pi will cancel, r power 4 divided by r square. This also will become r square. 1 by 3 pi r cube. Pi will be cancelled. R cube, that will become r when you divide with the r square. This pi r square, that will be completely eliminated. Okay. So now the remaining terms, we can write 2r pi 2r square. Okay. 2r square. 2r square. Okay. 2r square divided by 3. Plus, here you can see it has only r. So RH by 3. On the right hand side, 5r square divided by 12. Plus here again RH by 3. And then this side, that will be h square, that only the numerator, divided by 12. Okay. So here on the left hand side also RH by 3 is there. Right hand side also RH by 3 is there. That can be eliminated. So the remaining terms 2r by 3, here 5r square by 12, then h square by 12. Keep this 5r square by 12 on this side. Okay, this rearrange, we can write h square by 12, that equal to 2r square divided by 3 minus 5r square. Okay, 2r square. 5r square divided by 12. Then by taking the LCM, this has to be multiplied with 4 and 4. So we can write this term equal to, if you multiply it with 4, then this will be 4 multiplied with 2, that is 8r square minus 5r square whole divided by 12. Okay. Then we can write the top 3r square divided by 12. Okay. So h square by 12, this one, that we are getting 3r square by 12. So we can cancel this 12 and 12. Now taking the square root on both sides, then we can write h square equal 3r square. Then when you take square root, then will become h equal root 3r. And we know the value of root 3, that is 1.732 r. So when you know the value of radius, then the maximum height of the solid, that means right circular cone, in which the combined body may stand upright without topple, that height will be equal to 1.732, that is root 3 times of the radius of the hemisphere or the common face AB. Okay. Okay, guys, I hope you all understand this video. For more videos, don't forget to subscribe my YouTube channel, Vishwaguru, a problem solver. Okay. Thank you, guys. Thanks for watching.